Okay, we're going to talk about how to use linear functions to solve a problem. Step 1, identify the input and output values. Step 2, convert the data to two coordinate pairs, like an x and a y, or t for time and f of t if you have a function, whatever. Find the slope. Write the linear model. Use the model to make a prediction by evaluating the model at a given x value. And use the model to identify an x value that results in a given y value. Answer the question posed. So, first question. A company sells donuts. They incur a fixed cost of $25,000 for rent, insurance, and other exponents. Let me change to blue. Sorry about that. Other expenses. I say exponents. My mind is on math. It cost 25 cents to produce each donut. So write a linear model to represent the cost C of the company as a function of X, the number of donuts produced. So cost in terms of X donuts, we have that $25,000 fixed cost plus the 25 cent per donut cost. So the fixed cost and then the per donut cost. And that per donut cost is the variable cost. Of course, making donuts is how you make money. So you want to keep spending that because you're going to sell them for more than a quarter. So there's our function. It says find and interpret the y-intercept. So the y-intercept is going to be the constant part. The y-intercept is going to be, when x is 0, c of 0 is going to be 25,000. So the y-intercept is 25,000, which is the fixed cost. Let's go on to example 2. This population has been growing linearly, so it's growing in a line. That's a key point. It means it's got a constant growth. In 2008, we're going to call this time equals 0 here. The population was 28,200. So we have 0 corresponds to 28,200. By 2012, that means that's 4 years later, so t equals 4. The population was 36,800, so 4 corresponds to 36,800. So let's find the slope. 36,800 minus 28,000, 200 over 4 minus 0 is going to be, 8,600 divided by 4. So I get 2,150. So that's our slope. And we have a y-intercept. We defined a y-intercept. That was the best part. We got to define the y-intercept to be this. So the y-intercept. So if I do population at time t, it's going to be 2,150 times t plus the 28,200 that we started with when we started this formula. I did the other way, and it really works out to be, you'll still get there, but it becomes much more complicated. We can make this easier on ourselves, and we just did. So what is the population in 2014? So 2014, if we subtract 2008, we will have 6, right? So in 6 years from us starting this is 2,150 times 6 plus 28,200. I don't need the parentheses there. And that will be 41,100. So in the year 2014, there will be 41,100 people. And that's the answer to question 1. Question 2 says identify the year which the population will reach 54,000. So we take our 2,150 times t plus the 28,200 and set it equal to 54,000. We can subtract 28,200. So 2,150t equals if you can hear my calculator keys being pressed, 25,800. So 2150 t equals 25,800. Then we divide by 2150. And what does t equal? 12. 12 years after this starts. So 2008 plus 12, didn't line that up very well. It's going to be in 2020. So in 2020, they should have been at 54,000 people. Okay, hope that makes some sense. I want to really point out the key, though, is I indexed this to say t is 0 in 2008. So in 2012, it's 4 years later. That's why t is 4. And in 2014, it's 6 years later. That's why it's 6. And then when we solve this, t is 12. That means 12 years later than we started. That's 12 years later than 2008. Okay, moving on to example 3. Anna and Emmanuel start at the same intersection. Anna walks east at 4 miles per hour. So Anna walks east at 4 miles per hour. Emmanuel walks south at 3 miles per hour. They're communicating on a two-way radio that has a range of 2 miles. So I'm going to say call this 4t for time, 3t for time, because distance equals rate times time, and we're talking about a distance. So the question is, when are they going to be 2 miles apart? So how long after they start walking will they fall out of radio contact? So this uses the Pythagorean theorem, and 3t squared plus 4t, quantity I should say, squared, is 2 squared. So that's 9t squared plus 16t squared equals 4, or 25t squared equals 4. Divide by 25, t squared equals 4 over 25, or t equals the square root of 4 over 25. I kept it as the positive one because it's a principal square root, or I shouldn't say it's principal square root necessarily, but we can't have a negative time. So it's going to be 2/5, which is about, not about, is exactly 0.4 hours. So 0.4 hours times 60 minutes per hour. I'm probably doing more than I need to. Hours cancel. I'm doing some dimensional analysis. So in 24 minutes, they will be out of contact. I don't think it asks for minutes or hours. Like, I mean, I think 0.4 hours would have been fine, but that's 24 minutes. Okay. Let's see if I know if you can see that or not. It's right there. I'm looking at where the cutoff on my boundaries are. Okay, next. That's going to be the last one for this video. It's going to be a long video, so I'm sorry. Example 4, there is a straight road leading from the town of Timpson to Ashburn, 60 miles east and 12 miles north. From Timpton, so I'll call that T, to Ashburn, so call this A. It's a straight line, and they say it's going to be 60 miles east and 12 miles north. Partway down the road, it junctions with a second road perpendicular to the first road. And this is the road we're talking about. This is the road, so it's perpendicular to this road, and leading to the town of Garrison. If the town of Garrison is located 22 miles directly east of Timpson, so it must be like this. It didn't say how far, so I'm going to actually change that. It says Garrison's 22 miles, so I'm going to maybe put it like right here, so that this part is 22. Okay, where the whole thing is 60. Okay. If the town of Garrison is located 22 miles directly east of the town of Timpson, how far is the road junction from Timpson? So we want to know how far this junction point is going to be. Okay, this is a little bit complicated problem, but let me try to set up an axis system. So if we're putting at the origin our town of Timpson, and it's heading up here, and as I said, this was like 60 here, and then 20 or 12 there. This point would be located at 60, 12. Obviously, the origin is going to be at 0, 0. And then we have something that it hits here at this point, which is at 22, 0. This is 0, 0. Okay, so let's come up with the equation of this line here. And our slope is going to be 12 minus 0 over 60 minus 0, or 12 over 60, which is 1/5. So I'm going to call this the, I guess the Timpson Road. What's the other town called? Garrison. Call that point G. So our formula, and we know it goes to the origin, so that's going to be our y-intercept. It would be that t of x is going to be equal to 1/5 x plus 0, which is 1/5 x. And our slope there then is going to be 1/5. So if I look at this other line here, this g of x, and this g, I want to get the formula for g of x, that's going to be the negative reciprocal, so negative 5x plus some b. And we can get b by substituting the only point we know that's on there, 22, 0. So 0 equals negative 5 times 22 plus b. So that means 0 equals negative 110 plus b, or b equals 110. So our g of x is negative 5x plus 110. Now we want to find out where these two lines, this line and this line, intersect. So we take, I'm going to work over here, so 5x plus 110, set it equal to 1/5 x. And if I add 5x to both sides, I have 110 equals, so we have 1 over 5, by the way, plus 5 over 1. That's 1 over 5 plus 25 over 5 to give us 26 over 5 equals 26 over 5x. And so if I multiply both sides by that reciprocal, 5 over 26 times 5 over 26, that cancels. X would be equal to, so we have 110 divided by 26 times 5. That's not a good number. Sorry. I get 21.1538 as our x value. But that is the distance then that t is from G. So that's it. Now we could have, I think I could have made this harder, but I think that just about solves it, because that just gives us the x value of where they intersect. Or not where they intersect, that gives us the x value for the intersection, which, oh, that doesn't, no, I'm sorry, that does not give us the distance there. Hang on. Okay, that actually answers the question. I saw the answer key. This is 21.15. I thought they wanted to know another distance, but okay, that's it. We're done. I won't make this any harder. Sorry, already hard enough. So what I did was come up with the equation of the line from Timpson to Ashburn, and that's just the 1/5 x. then since this is perpendicular, negative reciprocal gives us the slope of the perpendicular line, and then I'm able to use the point we know, 0, 22, to get the value b, to come up with the equation of that line, which is negative 5x plus 110. I set the two equations equal to each other to give us this intersection point, and that's the x value of the intersection point. They didn't ask for the y value, just the x value, or actually that just gives us the point at which they intersect. So I think we're good there. Okay, just wondering if we need to find something else. Now that I've been thinking about this, I just paused it and thought about it. I'm not satisfied. This is what the answer key says, but I don't think that's correct. That's just the x value. So really, if I were to point that out, that is this value here. We need the y value too. So we need the y value. Sorry, that's this value here. We need the y value and the Pythagorean theorem to find this distance. So our corresponding y value, and I'll make it easy on ourselves, just do t of x is 1/5 times 21.1538, and that's going to be the y value. And let me get my calculator out here. That comes out to be 4.2308 if I round. So by the way, my calculator stored more digits than that, so I'm just rounding there. So now I'm going to look at the distance as the square root of these differences, not differences, square root of the x from 0 and the y from 0. So it's going to be this 21.15 squared plus 4.2308 squared. You can see a minus 0, but I'm just saving some time here. It's already running long on this video. So we end up with, let me square this. Plus the 21.1538 squared equals that. And I'm going to take the square root of that answer to give us 21.57. And they said it's 21.15, but I think that they stopped with just the x value. It needs to be this whole thing. So 21.57 miles. That's it. Okay, sorry for the long video. Okay, that's it for this one.